Remember, no names, have enthusiasm, ask questions, be yourself, is all the time.
Yes.
He's one of the most unfake people I know.
He is so real.
Yeah, you never front, do you? You don't.
I'm not an imaginary.
I've known him my whole life.
Isn't he just so straight shooter, down to earth? Cool. Okay, so he's gonna do 3, 2, 1, and then start capture.
Wait, how are we doing it?
Professor Shaniqua.
We'll do
MathemaSUNSHINE, I really like that.
MathemaSUNSHINE.
But his shirt.
3, 2, 1, go! Okay, good afternoon. Hearing the kids. What's my name? MathemaSUNSHINE is here for a lesson on solving systems by graphing. This should be a pretty straightforward lesson. I hope we get to it pretty easily. So let's define what we mean by a system first. You see on your paper, we have 2x plus 3y equals 12. If I wanted to plot points here, who can give us one easy point that is definitely on this line?
1.
What do you got here? 1 what? Point. What?
0.
1, 0, 0. When x equals 0, y would be, so 0, 4. So 0, 4 is true. Is 0, 4 on this line?
Yeah.
Is 0, 4 a solution to this equation?
Yeah.
Yes.
Yes.
Yes. If it fits in the equation, it's a point. Right. So let's actually go ahead and graph it. You can graph it on your paper. So we're getting 0, 4. I'm going to graph this one in blue. I'm about to tell you. Good job. I'm about to tell you. So 0, 4, 1, 2, 3, 4.
Mr. Dude.
Yes. Oh, you want one?
Yeah.
Cool. Like splayed out like a butterfly. Okay, so what's another point on this line? Yes, you need one too?
No, I have a question.
Oh, please, question.
Do you have to be pointed? Could you put them into slope-intercept?
Yes, we can put into slope-intercept. We're going to do that for the next line. But before we do that, I want to talk about what we mean by system, what we mean by solution. All right, so keep that in mind for the next line. What's another solution to this graph, please? You got one? Go ahead.
6, 0. X is 6.
6, 0, correct. 6, 0. So 6, 0 is a solution. So let's go ahead and put that one down. Oh, 1, 2, 3, 4, 5, 6. Should have done it in bleu. So there's bleu. Okay, maybe 1 or 2 more? Another solution?
Let's do 1.
Okay. I'm hearing no.
It doesn't work.
It will work, but it may not work cleanly, right? So if I wanted to do 1, 1 is a possible solution. If 1 goes here, this becomes 2, right? Subtract 2 on both sides, this becomes 10. So we'll get 3y equals 10. So y would have to be what?
10 over 3.
10 over 3 is sufficient? Yeah, 10 over 3. So we can go ahead and plot this point too. Much to the chagrin of the little kids. So 1, and what is 10 over 3 approximately? You said it?
3.3.
3 1/3. So maybe right here, a little past 3. Okay, give us one more that's whole numbers. Yes?
3, 2.
3, 2. Let's try 3, 2. 3, 2. Does 3, 2 fit inside this equation?
Yes, sir.
Thus, is 3, 2 on the line?
Yes.
Yes. Let's go ahead and graph 3, 2. Notice that they all line up. As you know, this is a linear equation. You can tell by how it looks like. This is a negative slope. That's correct.
I think that.
Right? Now, here's the question. Here's the question. How many solutions exist for this line?
An infinite
Yes.
number.
Bajillion.
An infinite number, we heard. Were you about to say that?
Infinity.
Not infinity. An infinite number. In other words, could I make this list go on an infinite number of times if I wanted to? Right? But would any number work in the world? Could anything work? Like 0, 0? Could 0, 0 work here?
No.
No. So not any number, but an infinite number. Right? So let's keep that in your mind. And let's start with the next equation that's right in front of you. Little Miss Sunshine in the back. Yes? You suggested putting this into slope-intercept form to graph. Let's go ahead and do that, everyone. Or you get y by itself, first by doing what to both sides? Subtract 2x, lovely. Negative y equals negative 2x, yeah, accents are fun, plus 4. And then do what to both sides?
Multiply by negative 1.
Right, multiply by negative 1. Basically, you can switch all the signs by doing that. And we're left with y equals 2x minus 4. Let's go ahead and graph that line.
But I thought it was, oh.
Let's graph the line. Minus 4. Oh, 4. I'm graphing this in green. Color coding is fun. 2 over 1. 2 over 1. 2 over 1. Okay, now we're going to define what we mean by system and what we mean by solution.
Is this perpendicular?
Do they have perpendicular slopes? I don't think so. No, they don't. The slope is negative 2 over 3.
But aren't they intersecting?
They are intersecting. So let me ask you a question. How many solutions existed for our first line? An infinite number of solutions. How many solutions would exist for this one?
Infinite.
Right? All these points on the green line are solutions. The question is, how many points or point work for both?
Oh,
One point works for
Find the
both.
intersection.
1 point works for both. And the point that works for both is where they intersect, correct? Does anyone know what that point is based on your graph?
The solution.
Yeah.
What that is exactly?
Oh,
3,
2, 3.
So we're getting 3, 2. So we already verified here that 3, 2 works. Let's verify that 3, 2 works over here. So 2 times 3
Yeah, it's right.
minus 2 equals 4. Is this statement true? Yes. So 3, 2 works for both. In other words, a solution to this system is the only point that will work for both. What's the only point that will work for both?
3, 2.
3, 2. Okay. Ready for the next one?
So the answer is 3, 2?
3, 2 is the answer.
Wait, so
Yes.
what exactly could you explain to me how you got the 3, 2?
We graphed both lines and we noted where they intersect.
Oh.
Where they
we didn't-
intersect is
Okay.
the solution to both.
Is there like a way we can figure that out without graphing it?
Yes, there is. It's called elimination and substitution. They're in the next sections of your packet. Very good question. That's right. So there's officially 3 ways of doing it. Graphing is one of them. Okay, so let's flip the paper and do the first line. Scene example B. We have 3 over 4. Do you love fractions?
No.
That's the spirit.
I love fractions, Mr. Dude.
Nice.
Wait, where are we?
Next page.
Oh.
Now, what's a good way to simplify this thing? Yes?
Denominator, which is 12.
Okay, you want to multiply both sides by 12? Let's do it. So if we multiply both sides by 12, go ahead and do that. Don't forget to distribute.
Can you just do the least,
This common multiple.
no, the y and x and
You could do y and x intercepts. That's possible. Like that. And multiply by reciprocal. Multiply by reciprocal. That's fine. That's fine. I would like to try it this way because I'm going to go somewhere with it. Okay, multiplying by 12. 12 times 3/4. What's 3/4 of 12?
9.
That's right. 9. Or if you want 36 over 4, that's 9x plus 2y equals 2/3 of 12 is indeed 8, right? Just distribute it. Or if you want, you can, of course, right, if you're doing 12 over here, 12 and 3 cancel, this becomes 1 and 4. 2 times 4 is 8, correct. Okay, getting y by itself,
Trash.
sounds like some massacre is going on. Negative 9x plus 8. But you guys enjoy the sound of children screaming, right?
Yeah.
Indubitably.
And then divide both sides by making y equals negative 9 over 2x plus 4.
Wait.
So, graphing. Yes, this is what the homework is. It's graphing. So graphing this one in bleu,
I have a question.
Plus 4, 1, 2, 3, 4, and take your question, please. Yeah.
For homework, do you recommend us using graph paper or can we just use notebook paper?
Graph paper will help you, but if you're precise with your graphing, you're going to do it. Okay, so we started at 4. Which way first? Up, down, left, or right?
Down.
Down 9.
Over
To the right.
To the right 2. 1, 2, 3, 4. 1, 2, 3, 4, 5 more makes 9. To the right 2. Here it is. Graphed it. Line. Okay.
Well, how do you assume that it's going to go like that? What if it goes like this?
Because this is a
It's a
linear
linear.
graph. We know that this is the equation of a line. I'm glad you asked. If you had things like squared or cubed, then it would not be a line.
I've seen those graphs that are like,
You're going like this. Yeah. No, this is a line just because it's mx plus b form. Okay, you notice the next equation is 9x.
Plus 2y plus 8.
9x plus 2y equals 8. Does this look familiar?
Yeah.
Like the same.
It's
standard
the
form.
same thing.
It's the same line. Here it is. 9x plus 2y equals 8.
Oh god. Oh
It's the
god.
same line.
Oh my god.
You're riveted, I can tell.
Josh is so excited.
So,
can we
who's
guess?
that?
Not,
Josephus.
I didn't know.
Josephus, yeah.
Josephus is so excited.
So now we're going to graph the second line. All right?
Forgot what
Where will it be?
On top of the
So on top of it.
On top of
No
it.
way. Oh, real numbers. Oh.
It's not all real numbers. I'm glad you got there.
There's an infinite
No.
amount of
It's infinite.
solutions.
Okay, so the answer is what?
There's an infinite amount
There's
of
an
solutions.
infinite number of solutions. Do you recall the last time that we did our graph? Let's stand over here.
But it can't be
We
all real
noted,
numbers.
hold on, I'll tell you. We noted where the two lines intersect. Because where the lines intersect is a solution for both, correct? And the point that they intersected, the last one, was the point 3, 2. Where do these two lines intersect?
Everywhere.
Not everywhere.
Infinite.
Finding on the whole
Never.
line.
Everywhere on the line.
That's what I.
Correct. Everywhere on the
Yeah.
line. In other words, will any number work for these lines?
No.
No.
Not
Good job.
necessarily.
Not necessarily. Like the point 0, 0 will not work for both of these lines.
So it just can't be all real numbers. It has
It's
to be.
not all real numbers. The answer
It
is
has to be the-
Is it the equation itself?
Isn't it just the conclusion?
Oh, infinite solutions. Okay.
infinite solutions means there's an infinite number of points that will work for both because in fact they are the same line. We
But-
graphed the same line twice.
But it's not all real numbers.
It's not all real numbers.
solutions. It's only
It's not all solutions. There's an infinite number of solutions. Let me give you an example. Even numbers. Is that an infinite number of numbers?
Yes.
Even numbers, right. But is that all numbers?
No.
No.
it's only even numbers.
Right. It keeps going and going infinitely many times, but it's not all. Just like over here, there's an infinite number of points on these lines, but not any point works. Okay, so that's the difference. It would be wrong to write all real numbers. It is sort of interesting. All real numbers is not infinite. Okay. One more.
I just hurt my shoulder doing that. So my cousin. Painful.
Next one. You guys are really touching me with that level of concern you're showing. Thank you.
Now you're over.
Even then. It's just like. Okay.
Oh, it's coming.
More.
Let's graph this one. This is already in y equals mx plus b form.
So for
Something like
me,
that. So you can go ahead and graph. Yeah. Got up one over here. And I'll graph this one.
Wait, where is this?
This is the third problem.
It's 2x minus 2y.
No, the first one I'm graphing. Just
Oh.
I changed the order.
Oh.
I changed the order, so I brought
The first one, though, is in slope-intercept form, right?
It sort of already is, right? I just brought y to the left.
Got it.
Right, there. There's one line. And then the second line. What's it say?
It
2x
says
minus 2y.
2x minus 2y equals 8, good. And then we have slope-intercept form again.
4z. Oh, I just x y'd it. X y.
Oh, you want to do,
I don't mind. Whatever you like.
we could do it that way. Yeah, it's totally fine. So the x-intercept is at 4, put that there.
Y equals x minus 4.
Yeah. It's there. I'm going to go ahead and put it in slope-intercept form just to make a point. we have negative 2x, negative 2x, negative 2y equals negative 2x plus 8. Divide both sides by negative 2. Y equals x minus 4. Is that what you said?
Yeah.
Yeah, you're right. So these are the two equations of our lines. What do you notice about these lines?
They are parallel.
Parallel.
Indeed, they are parallel. You gonna say that, Miss Sunshine? Yeah, they are parallel.
So there's no substitution.
So 1, 2, 3, 4 here. And there's... Isn't the question, where do these two lines intersect? It was the first problem we did. They intersected at one point.
These never do.
It was in the second question. The question was, you're right. Where do the two lines intersect? They intersect infinite number of times because they overlap. That was the second one. The third one, where do these two intersect? Do
Never.
they? Never.
No solution.
So no solution.
If they have the same slope, does that mean that there's no solution?
Undefined.
Very good. That's exactly one step ahead. When there's the same slope, you know that there will be no solution if they're different lines. But if they're the same line, it's infinite number of solutions.
Oh, that's already.
So who can raise their hand and give a summary of the three scenarios?
Oh, I can.
Let's go here. Yeah.
Okay. So the first scenario, we had two different equations of a line,
Okay, two different lines.
and we graphed them, and they intersected at one specific point.
And that point is the
That point is the one solution.
one solution. Very good. To the system of two lines. Very good.
So then we had B, which we realized that the two equations were actually the same line.
Same line.
So they had an infinite number of solutions
Because how many points?
because they're on top of each other.
Right. Meaning how many points do they intersect?
An infinite number.
Right. They do intersect an infinite number. Third scenario.
Is two lines that have the same slope, so they're parallel,
Parallel.
and there's no solution because they never intersect.
Very good. All right. Those are the three. One solution, many solutions, or no solution. Okay. Good job. So we have time. You guys can start your homework in class. Does that sound good? Yeah, let's do a little graphing. Sure. Okay, say bye, everyone. Bye.
Hey, Matt.